Good day everyone. Our group is to present instruction sets, addressing modes and formats. The first topic will be addressing modes. First of all, what is addressing modes? Addressing modes is defined as the different ways in which a processor can access data. Addressing modes are an aspect of the instruction set architecture in most central processing units are commonly referred as CPU designs. It is a method by which a computer network can identify which device sent a piece of information over the network and which device received that. An addressing mode specifies how to calculate the effective memory address of an operand by using information held in registers and are constants contained within a machine or instruction or elsewhere. What are the terms that we are going to encounter in this report? First of all, the operand. Operand is the part of a computer instruction that specifies data is to being operating on the manipulated and by extension the data itself. The other term is the register. The register is one of a small set of data holding places that are part of a computer processor. A register may hold a computer instruction, storage address, or any kind of data such as the bit of sequence or individual characters.
The first kind of addressing is immediate addressing. Operand is the part of instruction. No memory reference to fetch data. Size of the number is restricted to the size of the address field. And the second kind of addressing is direct addressing. Single memory reference to access data. No additional calculations to get effective address. Address space is limited to the size of the address field. Address field contains the address of operand. EA equals A. EA which means effective address and A means address field. And the third kind of addressing is indirect addressing. Memory cell pointed to by address field contains the address of the operand. And multiple memory accesses to find operand. EA equals A.
In register addressing, operand is held in register. Fast execution is possible. EA equals R. R means register. Register indirect addressing. Operand is in memory cell pointed to by contents of register R. EA equals R in parentheses. Displacement addressing. Combine the capabilities of direct addressing and register indirect addressing. EA equals A plus R in parentheses. Instruction has two address bits. A equals base value. R equals register that holds displacement.
By 86 addressing modes. By 86 address translation mechanism produces an address called a virtual or effective address that is an offset into a segment. Associated with each user visible segment register is a segment descriptor register, not programmer visible, which records the access rights for the segment as well as the starting address and limit or length of the segment. For the immediate mode, the operand is included in the instruction. The operand can be byte, word, or double word of data. For register operand mode, the operand is located in the register. In the displacement mode, the operand's offset is contained as part of the instruction as an 8, 16, or 32-bit displacement. So as you can see, here is the example of table of by 86 addressing modes. The example of uses of this mode. Use a compiler to point to the start of a local variable area. Use to index into an array where the element size is not 1, 2, 4, or 8 bytes, and which therefore cannot be indexed using an index register. Used to access a field of a record. In the scaled index with displacement mode, the instruction includes displacement to be added to a register. in this case called an index register. While the base with index displacement mode sums the content of the base register, the index register, and the displacement to form the effective address. And the base scaled index with displacement mode sums the contents of the index register multiplied by a scaling factor, the contents of the base register and the displacement. And finally, the relative addressing can be used in transfer of control instructions. And by 86 addressing modes, here the examples also in virtual of effective address is offset into segment. And first, starting address plus offset gives linear address. Second, this goes through page translation if paging is enabled. So in 12 addressing modes available, these are the 12 addressing modes: immediate, register operand, displacement, base with displacement, and base, scaled index with displacement, base with index and displacement, base scaled index with displacement, and relative.
Or typically a RISC machine or the reduced instruction set computing, unlike a CISC machine, uses a simple and relatively straightforward set of addressing modes. The ARM architecture departs somewhat from this tradition by providing a relatively rich set of addressing modes. Load or store addressing. Load and store instructions are the only instructions that refer to memory. This is always done indirectly through a base register plus offset. Offset, for this addressing mode, indexing is not used. An offset value is added to or subtracted from the value in the base register to form the memory address. The pre-indexed memory address is formed in the same way as for offset addressing. The memory address is also written back to the base register. In other words, the base register value is incremented or decremented by the offset value. Post-index memory address is the base register value. An offset is added to or subtracted from the base register value, and the result is written back to the base register. Data processing instruction addressing is used either register addressing or a mixture of register and immediate addressing. The branch instructions are the only form of addressing. For branch instructions is immediate addressing. The branch instruction contains a 24-bit value. For address calculation, this value is shifted left 2 bits so that the address is on a word boundary.
Format. Instruction format is the part of the computer architecture related to programming. In an instruction format, we include the native data types, the instructions, the registers, the addressing modes, the memory architecture, the interrupt and exception handling, and external input-output. In selecting the instruction formats, the following factors should be considered. We considered 5 factors. Number 1, the number of instructions to be represented. Number 2, the addressability and addressing modes. Number 3, the ease of decoding. Number 4, type of instruction field, fixed or variable. Number 5, the cost of hardware required to decode and execute instructions. Instruction and data formats for PDF. In instruction and data formats for PDF, we compare the instruction formats and the data format. In an instruction format, there are 2 addresses, the 1 address and the second and the 2 address. In 1 address, there are OP code, the mode, and the register. In OP code, there are 10 bits. In a mode, there are 3 bits, and in a register, there are 3 bits. In a 2 address, there are OP code, the mode, the register, and another mode in a register. In an OP code, there are 4 bits. In a first mode, there are 3 bits. In a first register, there are 3 bits. The second mode has 3 bits, and the register has 3 bits. The first mode and the register is what we call the SRC, and the second is the DST. In a branch, there are opcode and offset. The opcode has 8 bits and the offset has 8 bits. So we had a formula for branch address, the updated PC plus the 2x offset. In a data format, there are 16 bits. We divided it with 2 complements in a character. In the first character, we had 8 bits, and in the second character, there are 8 bits. Basic instruction format in PDP-11 address field. In a PDP-11 address field, we had an opcode and an address. In an address, we had a mode and a register. In a mode, we had a register, auto-int, auto-dec, and an index. Register has the value of 0000000. In an auto-int, we had a value of 01001. In an auto-dec, we had a value of 100. And in an index, we had a value of 110111.
Instruction formats for PowerPC. There are 6 kinds of instruction formats. First, the 2-operand general instruction format. It is consist of opcode, destination register or source register, an additional register, and an immediate operand. The second is the 3-operand general instruction format. It is consist of opcode, destination register or source register, an additional register, a third register, a setting flags, and the sub-opcode. The third is the instruction format for comparing. It is consist of opcode, a comparing field, an OPC, the third register, and an immediate operand. The fourth one is the second instruction format for comparing. It is consist of opcode, a comparing field, an OPC, an additional register, and the third register, a sub-opcode, and an offset value. The fifth one is instruction format for logical operations with the use of conditional register bit. It is consist of opcode, a CRBD, a CRBA, CRBB, and the sub-opcode. The sixth one is the instruction format for shift or rotate operations. It is consist of opcode, a source register, an additional register, a shift or rotate, the mask begin, a mask end. Instruction format for Motorola. It is consist of operation word. First word specifies operation and modes. Immediate operand, if any, 1 or 2 words. Source effective address extensions, if any, 1 or 2 words. Destination effective address extension, if any, 1 or 2 words. Single effective address instruction operation word general format. The address is 15 to 6 composed of offset values, while the address is 5 to 0 contains the effective address which has the mode or register. Pentium general instruction format. Instruction prefixes. It is up to 4 prefixes of 1 byte each. An opcode with 1 or 2 byte. A mod RM, if required, it has 1 byte, and it is composed of mod, register, opcode, and an RM. A SIB, if required, it is also consists of 1 byte, and it has scale index base. A displacement, address displacement 1 to 2 or 4 bytes or none. An immediate data 1, 2 or 4 bytes or none.
There are 9 types of by86 instruction formats. It is the instruction prefixes, segment override, operand size, address size, opcode, mode R or M, SID, displacement, and immediate. The first one is the instruction prefixes. The instruction prefix, if present, consists of the LOCK prefix or one of the repeat prefixes. So the lock prefixes is used to ensure exclusive use of shared memory in multiprocessor environments. The second one is the segment override. Explicitly specify which segment register an instruction should use, overriding the default segment register selection generated by the by86 for that instruction. The third one is the operand size. An instruction has a default operand size. It can be 16 or 32 bits. And the operand prefix switches between 32-bit and 16-bit operands. The fourth one is the address size. The processor can address memory using either 16 or 32-bit addresses. The address size determines the displacement size in instructions and the size of address offsets generated during effective address calculation.
The fifth one is the opcode. The opcode field is 1, 2, or 3 bytes in length. The opcode may also include bits that specify if data is bytes or full size. Direction of data operation and whether an immediate data field must be sign extended. The sixth one is the mode RM. This byte and the next provide addressing information. The mode RM byte specifies whether an operand is in a register or in memory. The seventh one is the SID. Certain of encoding, the mode RM byte specifies the inclusion of the SID byte to specify fully the addressing mode. The eighth one is the displacement. When the addressing mode specifier indicates that a displacement is used, an 8, 16, or 32-bit signed integer displacement field is added. The ninth one is the immediate. It provides the value of an 8, 16, or 32-bit operand. Several comparisons may be useful here. In the by86 format, the addressing mode is provided as part of the opcode sequence rather than with each operand.
ARM instruction format, ARM, originally Acon RISC machine, later advanced RISC machine, is a family of reduced instruction set computing, or RISC, architectures for computer processors configured for various environments developed by British company ARM Holdings. ARM operation types, load and store instructions. It is the ARM architecture only load and store instructions access memory locations, arithmetic, and logical instructions. Branch instructions. ARM supports a branch instruction that allows a conditional branch forwards or backwards up to 32 MB. Data processing instructions. This category includes logical instructions like AND, OR, XOR, and subtract instructions, and test and compare instructions. Multiply instructions. The integer multiply instructions operate on word or half-word operands and can produce normal or long results. Parallel addition and subtraction instructions. In addition to the normal data processing and multiplying instructions, there are a set of parallel addition and subtraction instructions in which portions of two operands are operated or in parallel. Extend instructions. There are several instructions for unpacking data by sign or zero, extending bytes to half-words or words, and half-words to words. Status register access instructions. ARM provides the ability to read and also to write portions of the register. Here are the condition codes. N is for negative, which is set if the result of a data processing instruction was negative. Z for 0 is set if the result was 0. C or carry is set if an addition, subtraction, or compare causes a result bigger than 32 bits, or is set from the output or the shifter for move and logical instructions. And V or overflow if the set is an addition, subtraction, or compare that produces a signed result bigger than 31 bits. Here is the diagram for the ARM conditions for conditional instruction execution. And here is the complete diagram of the our instruction set format.